Alright, so here you have the last kind of stoichiometry, so mass x to mass y. So this is the last one, and we'll be practicing this for a bit longer, so but this is the last kind you need to know. So for these problems, you'll be going from grams of something x into grams of something else y. This is going to require 3 conversion steps or 3 division bars. And so step number 1 is balance the equation. And so I'm going to do an example like I did before, so that way you can kind of see step by step what you do. So I'm going to balance this equation here. So let's write this out. Ca is 1, Cl is 2, Na is 1, and then NO3 is polyatomic, and that's 1. And then Ca is 1, and then Cl is 1, and Na is 1, and then NO3, the polyatomic, is 2. Alright, so something not balanced is the Cl's, so I could put a 2 here. That would give me the 2 Cl's I wanted, but it also gives me 2 NA's. And then if I give myself 2 NA's over here, this will give me the 2 NA's, but it also gives me 2 NO3's, and that's fine because I want that. So now this is balanced. So that was step 1, balance the equation. So step 1 was balance the equation. Step 2 is write the starting mass and units which are given in the question, which is always the same step 2. That doesn't change at all. Starting mass and units would be 3.50 grams, that's the starting mass, and units would be grams of CaCl2, and that is just given to me in this problem right here. Right there. So that was step 2. Step 3 is draw a division bar. So draw my division bar. Step 4 is to write 1 mole on the top and the molar mass on the bottom of the starting compound. Or another way of putting that, like I always do, is take your starting unit and put it on the bottom, which is going to be grams of CaCl2. And like I've said probably 20 times by now, whenever you have grams, you're always going to pair that with moles. Grams always goes with moles, and the compound should be the same. So if it's CaCl2 grams, then it's CaCl2 moles. These should always be the same compounds. This mole will then always be 1. This grams will come from a periodic table. So I'll get a periodic table here. Ca is 40.08, and Cl is 35.45, and it's CaCl2, so it's going to be 35.45 times 2, and then add that to Ca, which is 40.08. So that is 110.98. I'm kind of getting ahead of myself though, because I think I jumped ahead of the notes. So let's go back for a second here. Oh no, it does say 1 mole on top and the molar mass on the bottom, so I did that. Next step, write a multiplication symbol and draw a division bar. So I can do that. Multiplication symbol, division bar. Next step is write a molar ratio with moles of what you start with on the bottom and moles of what you end with on top. So I gotta do the mole to mole bridge to get me to the moles of the other thing I want. So the moles of your starting compound goes on the bottom, moles of CaCl2. And then the ending compound, gotta go back to the question for this. So it says if you have 3.50 grams of CaCl2, how many grams of NaCl? So this is going to be moles of NaCl. Alright. Now, when I have moles over moles, then I look at my equation to get those numbers. So NaCl has a 2 in front of it, and CaCl2 has nothing, so that's a 1. Oh, I'm getting ahead of myself. Alright, next up, write a multiplication symbol, draw a division bar. So multiplication symbol, division bar. Let me fix that. Try to do that a little straighter. Alright, next step is write the molar mass on top and 1 mole on the bottom of the ending compound. So I take my unit on top and I move it to the bottom. So this will be moles of NaCl. And then the molar mass of the ending compound is going to go on the top. So this will be grams of NaCl. And that's what I need. I need grams of NaCl, so that's why that's my top compound. Grams and moles are together, so this mole is 1, and grams comes from the periodic table. So Na is 22.99 and Cl is 35.45. So that is 22.99 plus 35.45 is 58.44. 58.44. The last step is solve, so I'm going to take my calculator, and you always just, work your way left to right, typing it in, to multiply by the top, divide by bottom. So 3.50 times the 1 on top is going to give me 3.50. And then divide by the bottom, which is 110.98. That's the first step. Now the second one is multiply by 2 on the top and divide by 1 on the bottom. So I'm just going to do times 2 because dividing by 1 gives me the same number. And then I multiply by 58.44. So times 58.44. So long little answer, always round to just 2 numbers after the decimal. After the 8 though, there is a 6, so this 6 is going to round that 8 up to a 9. So 3.69 should be your answer here. And I'm going to actually just write it up here in this space. 3.69. And then let's look at units, because that's very important. So your diagonal units should cancel each other. These should be the same, then they go away. These units are the same, so they go away. These units should be the same, so they go away. So diagonal units should always match. That should always leave you just 1 unit on the top, and that should also become your final unit, which is grams of NaCl. And so you can see it's very similar to what you've already been doing. It's just a little bit longer, but the steps are pretty much the same for all stoichiometry problems. So don't get caught up in like, oh, is this a moles to moles, a mole to mass, whatever. It doesn't matter. You always kind of solve them all the same way. Alright, so let's continue. I'll do a couple more here, and then I'll leave you a few to do on your own. So I've got 3Ks on this side, so I need 3Ks on this side. That gives me 3 Cls on this side as well, so I need 3 Cls over here. And then I have 3 H's, and I already have 3 H's, and my PO4s are done, so everything is balanced. So start by writing what you have. 328.5, and then grams of HCl. And then the next step is always going to be to draw your division bar. Take your starting unit and put it on the bottom, grams of HCl. Whenever I have grams, that always pairs with moles of the same thing, HCl. Grams and moles should always be the same compounds. This mole will then always be 1 wherever it's paired with grams, and then I need the molar mass off the periodic table, HCl. So H is 1.01 and then Cl is 35.45. So clear this. 1.01 plus 35.45. I guess I could probably do this in my head because it's 36.46. And so then this will be 36.46. Alright, next one. So in a 3-step division bar, the middle one is always going to be the mole to mole one. Alright, so I take my starting unit here, moles of HCl, move it to the bottom. And then it's a mole ratio, so it's going to be moles of the other thing that they asked me for, which is H3PO4. Now they didn't ask me for moles of this compound, they asked me for grams, but I can't go directly to grams from moles of something else. I have to first go through moles. So this is why we need a mole ratio here, so we can transition from our first compound into our second. This is mole over mole, so the H3PO4 is 1 because there's nothing in front of it, and the HCl is a 3. Third division bar, take your top unit, start here, and move it to the bottom. So moles of H3PO4, and just remember your diagonal unit should always be the same, H3PO4. And then what they asked me for is grams of H3PO4. So I'm going to do that conversion right here in this division bar. Alright, when grams are with moles, this mole is always 1. This mass comes from the periodic table, so it is H3, which is 1.01 times 3, and then I'm going to add that to P. So P is 30.97 plus 30.97, and then it was O4, right? Yes, PO4. So O is 16, so add 16 times 4. So 98. So this mass is 98. Now you solve, start on the left side, work your way to the right, multiplying by the top, divide by the bottom. So we start with the starting one, which is 328.5, and then it is divide by 36.46, and then the next division bar is multiply by 1, divide by 3. Now on to the last division bar, which is multiply by 98. And so the answer is 294.32. 294.32. And this is grams of H3PO4. Every problem that you do, you need to show your work, and you need to include units in the problem. Very, very important. You can go back and cancel your diagonal units. They should be the same, so they should cancel each other. Okay? And that's kind of like one last clue that you did things correctly. Alright, on to the next problem. So first thing is to balance the equation. I'm going to need a 4 here because I have 4 C's on this side, and then I'm going to need a 5 here because I have 10 H's right there. And then my O's, I've got 8 and 5, and so this is one of those situations that kind of raises a red flag to me that I'm going to have an odd number on one side and an even number on the other. And so I'm going to have to do that decimal. So I'll have to balance it with the decimal. So here is 8 O's, and then I have 5 over here on this side. So 8 plus 5 is the 13. And so I need, over here, what times 2 is going to give me 13. And so that would be 6.5. And then I have to get rid of the 0.5 by multiplying everything by 2. So this becomes a 2. This becomes a 13, this becomes an 8, and this becomes a 10. Alright, so start by writing what you have. So I have 243.5 grams of C4H10. Okay. And then draw your division bar, and then take your starting unit and put it on the bottom. Grams of C4H10, and then pair that with mole, because grams always pairs with mole, and of the same compound, C4H10, and that mole is always going to be 1. Then I need my mass off the periodic table, so C is 12.01 and H is 1.01, so it's C4H10, so that would be 12.01 times 4, and then add that to 1.01 times 10, and so that's 58.14. Alright, next division bar. So this will be moles of C4H10, and then moles of the other compound I want to convert into. And if you look here at the question, they said H2O, and then also I have some O2, but this says excess O2, and remember, whenever something says excess, it's just letting you know it's there, and it's not going to stop your reaction, but you don't need it. So the one I do want is this one, the H2O. So H2O. Alright, I have moles over moles, so I am going to look at my balanced equation to get those coefficients. So H2O has a 10 in front of it, and C4H10 has a 2. And then next division bar, take your top unit, moles of H2O, and then I'm going to go to grams of H2O because that's what they asked me for, and so that needs to be my last unit on the top. And then this is going to be 1. H2O would be 1.01 times 2, which is 2.02, and then plus 16, so that's 18.02. And then we solve. So take your calculator, start on the left, so 243.5, and then divide by the 58.14 equals, and then in the middle I had 10 over 2, so I'm going to multiply by 10, and then I'm going to divide by 2, and then the last division bar was 18.02 over 1, so it's going to be multiply by 18.02 and then divide by 1. Alright, 377.35. So the answer is 377.35. And just round your answers to 2 numbers after the decimal, and then this will be grams of water, because that's what they asked me for. And then one thing you can do is cancel your units. Just make sure your diagonal units are the same. Diagonally they should be the same. Diagonally they should be the same. And if that's the case, then you did a good job there setting that up. Alright, on to the next one. So I have KClO3. I need to put a 3 here, and a 2 there, and then a 2 there. So I have 89.756 grams of KCl. And then I draw a division bar. I try and draw a division bar straighter than that. Alright, nope, I didn't do much better. Grams of KCl. And then on the top I put moles of KCl because grams always goes with moles and the compounds should be the same. And then this mole should be 1. Grams of KCl comes from the periodic table, so K is 39.1 and Cl is 35.45, so 39.1 plus 35.45, 74.55, 74.55. Alright, next division bar. Take your top unit, move it to the bottom. So this will be moles of KCl. And then on the top, it will be moles of the other compound that they asked you to convert into. So I started with KCl, they asked for O2. So I need to go to moles of O2 first before I can go to grams of O2. I have moles over moles, so I look at the equation. Here, this is going to be a 3. This is then going to be a 2. And then next division bar, take your top unit, move it to the bottom, moles of O2. And then the top is going to be grams of O2. Oxygen is 16, so that's going to be 32, because it's 16 times 2, 32.0 we'll say. And then grams is with moles, so that mole is 1. Now you solve, so put in your starting number, 89.756, divided by 74.55, and then the middle one was 3 over 2, so times 3, divide by 2, and then the last one was 32 over 1. So I'm going to multiply by 32 and then divide by 1. 57.79, so this will be 57.79, right? It was 57.79, yep. And then grams of O2. And then one last thing to do is to check the diagonal. Do the diagonal units match? If they do, then you set this up correctly, and if they don't, then you set that up incorrectly, and what you should be left with is a top unit, which should always become your unit for your answer, it should also match what they asked you for in the question. And those are just some hints as to, what you can do when doing stoichiometry. That leaves you number 4, number 5, and number 6 to do on your own, and I will give you the answers to those on the assignments page, so that way you can check and make sure that you're doing those correctly.